Hi, welcome to the 6th algebra tutorial, Inequalities. Today's tutorial is a follow-on from the previous tutorial which dealt with fractions and equations. In terms of what you need to know to progress with this tutorial, you need to be familiar with your grade 10 work. You also need to have gone through the first 5 algebra tutorials. We will begin this tutorial by looking at a definition of inequalities, and then we are going to go through a few expressions that are pertinent to inequalities. Inequalities. Now let's think about that word, inequalities. In, equal, unequal. Thus far we have dealt with equations where the left-hand side has been equals to the right-hand side. With inequalities, the opposite is true. The left-hand side is not equals to the right-hand side, which means that it's either greater than or it's less than the right-hand side. We will now look at the 4 basic expressions that are pertinent to inequalities. The first expression is this one over here. This means that the left-hand side is greater than the right-hand side. If I say for instance, x is greater than 2, it means that x can have any value bigger than 2. X can be equals to 2.1, it can be equals to 3, 4, 5, 10, anything greater than 2. If I try and represent that on a number line, let us bring up a number line over here. If I put 2 in over here, x can be any value on the right hand side of 2. The way I'll denote that is I'll use an open circle with an arrow. This means that x is not equals to 2, but it's everything bigger than 2. The next expression we're going to use is this one over here. This is almost the same sign as we used previously, except it has that little line underneath it. This means that the left-hand side is greater than or equals to the right-hand side. If I say x is greater than or equals to 2, it means that x can hold any value bigger than or equals to 2. So it can be 2, or 2.1, or 2.2, or 3, or 4, or 5, or anything bigger than or equals to 2. The way I represent that on my number line is I'll put a closed circle over the 2 with an arrow attached to it, also pointing towards the right. The next expression we're going to look at is the opposite of the previous 2. This expression over here. Now this expression means that the left-hand side is smaller than the right-hand side. If I say x is less than 2, it means that x is any value smaller than 2. Again, looking at the number line, if I put 2 over here, it means that x is any value smaller than 2, any value to the left of 2. It can be 1.9, it can be 1, it can be 0, it can be -1, anything smaller than 2. The way I'll denote that is with an open circle and an arrow. The 4th sign we're going to look at is this one over here. Now this means that the left-hand side is smaller than or equals to the right-hand side. If I say x is less than or equals to 2, it means that x can equals 2, and it can also equal anything smaller than 2. The way I'll denote that, again with a closed circle and an arrow pointing to the left of 2. Don't worry too much about the way we denote these. We will go more in depth into the notation later on in this tutorial. We are going to start by looking at a few rules for tackling equations that are in inequality form. Rule 1. Solve as if it were a normal equation, but do not find the final values. Rule 2. Move on to the number line with the critical values. 3. Use test points to find out which parts of the number line are going to be positive and negative. And rule 4, find the solution, solve for x. Now, all of these rules will sound a little bit foreign to you if you haven't come across this section before. Not to worry, as we progress through the next example, you will see what I mean by all of that. Example: x is less than or equals to 3x minus 8 over x minus 3. Solving it as a normal equation would yield x times by x minus 3 is less than or equals to 3x minus 8. All we've done there is multiplied out the denominator of x minus 3. That will give us x squared minus 3x is less than or equals to 3x minus 8, which would yield x squared minus 3x plus 8 is less than or equals to 0, giving us x squared minus 6x plus 8 is less than or equals to 0, and that can be factorized into x minus 4 times by x minus 2 is less than or equals to 0. Stop at this point. Now, in a normal equation, we would have solved it and said that x is equals to 4 or x is equals to 2. But this is not equals to 0, this is less than or equals to 0. Hence, those two values, x equals to 4 and x equals to 2, are going to form our critical values. Our critical values are the values that turn our equation into 0. Please note that there's one other critical value, and that's x minus 3 cannot equal 0. Now remember, from the 5th algebra tutorial which dealt with fractions, we saw that we needed to state our restrictions. In this example here, our restriction is x minus 3, which was our denominator, cannot equal 0, which means that x cannot equal 3. So our three critical values are x is equals to 4, x is equals to 2, and x equals to 3. Take those critical values and put it on a number line. The first value we're going to put is 2, then 3, then 4. Now, I need to put test points in so that I can solve for this equation. The first test point I'm going to use is I'm going to use 0. Now you will notice that 0 is smaller than 2, right? 0 or 1 or anything less than 2 could be used as the test point for everything to the left of 2. If I put 0 in, we'll have 0 minus 4, which is negative 4, times by 0 minus 2, which is negative 2. A negative times a negative is a positive. That means that on the left hand side of 2, our number line is positive. That means that between our next two critical values, i.e. 2 and 4, it's going to be negative, except it cannot equal 3. Keep that in mind. Our equation cannot equal 3, so we're going to put an open circle on the 3. The next point, the next part of the number line rather, is everything greater than 4, and that's going to end up becoming positive. Notice in all of these examples, we only really need to put in one test point, and it follows the pattern positive, negative, positive, negative, or negative, positive, negative, positive. Now, we are looking, let us just take a look back at the end of our example. We had x minus 4 times x minus 2 is less than or equals to 0. Less than or equals to 0 means that we are looking for where it is negative. Now take a look at the number line. It is negative between 2 and 4, and it cannot equal 3. The way we're going to write that out, we are going to say, therefore, x is greater than or equals to 2. The reason being greater than or equals to is because we're looking for when it's less than or equals to 0. Or rather, there's a closed circle on top of the 2. So x is greater than or equals to 2, and at the same time less than or equals to 4. But, and we have to put this in, x cannot equal 3. And then we have solved for it. We found that x can hold any value between 2 and 4 except for the value 3. This is one form of notation. Another form of notation we can use is we can say that x is an element of square bracket 2 all the way up to 4 square bracket again, but x cannot equal 3. That restriction is very important. We have to put it in all the time. Just a quick note on this last notation that I've used. The square brackets are associated with the greater than and equals to sign, or the less than or equals to sign. The square bracket includes the last number. So in this example, the square bracket means that the x values could include 2 and could include 4. The other brackets we have are the round brackets, and the round brackets are applicable when we're working with either greater than or less than signs. Notice something, the round bracket is very similar to an arrow shape, which means that it's sort of pushing the last one out, whereas the square bracket is sort of like a box shape, which means that it's boxing in that final value. Now I want you to have a go at the following examples. Press pause on your DVD player, and when we return, we'll go through it. The first one I gave you to do read 9x minus 4 divided by 3x plus 1 is greater than or equal to 2. I'm going to tackle this the same way I tackle fractions. Start off with LCD, and that's 3x plus 1. Remember, that's over 1. That means that 9x minus 4 is greater than or equal to 2 times 3x plus 1. That means that 9x minus 4 is greater than or equal to 6x plus 2. Take the 6x across, that gives us 9x minus 6x is 3x, greater than or equal to 2 plus 4, which is 6. That means that x is greater than or equal to 2. Now remember, our LCD was 3x plus 1. That means that 3x cannot equal negative 1. X cannot equal negative 1 over 3. Does this follow that? Yes, it does. It says that x is greater than or equal to 2. Greater than or equal to 2 does not include negative 1 over 3. So that's fine. Let me just draw that on a number line. Negative 1 over 3 is somewhere over here, 2 is over here. X is greater than or equal to 2, which means that we're looking for all of those values, not including anything below it, so that's all good. (3x plus 7 is less than or equal to negative 6x minus 4 over 5. This is an easy one. Our LCD is 5. Just multiply it in. That means that 15x plus 35 is less than or equal to negative 6x minus 4. Negative 6x taken across will take us to 21x, is less than or equal to negative 4, take the 35 across, which makes it negative 39. That means that x is less than or equal to negative 39 over 21. Number 3 read x plus 4 divided by x greater than or equal to 3x over x plus 2. Now our LCD in this case is equal to x multiplied by x plus 2, which means that x cannot equal 0 and x cannot equal negative 2. Keep that in mind. This is extremely important, especially with inequalities. If our LCD is that means that this is going to become x plus 4 multiplied by x plus 2 greater than or equal to 3x times x, which is 3x squared. That means that x squared plus 4x plus 2x plus 6x plus 4 times 2 is 8 is greater than or equal to 3x squared. Take the 3x squared across, that gives you minus 2x squared, because that's 1x squared minus 3x squared is minus 2x squared, plus 6x plus 8 greater than or equal to 0. Now you know that I don't like working with a negative in front of the x squared, and also the 2 can be divided through. So divide through by negative 2, which will give us x squared minus that positive, because I'm dividing by a negative, becomes negative 6 divided by 2 is 3, x minus 4 is, here's an interesting one. Because we've divided through by a negative, we change the direction of the sign. If I had negative 4x is equal to 12, it's easy to say x is equal to 12 over negative 4, which is negative 3. Because my equal to doesn't have a direction. If it was minus 4x is greater than 12, dividing through by minus 4 would lead to the sign changing direction. In inequalities, golden rule, whenever I divide by a negative, the direction of my sign changes. In this case here, that is going to change direction to be less than or equal to 0. We can very easily factorize this one. This will simply become x minus 4 multiplied by x plus 1 less than or equal to 0. That means that our two critical values are negative 1 and positive 4. These are the values that makes this whole expression equal 0. Can it equal 0? Yes, it can. So we use the closed circle, closed dot. Because I factorized from a positive a value or a positive value in front of the x squared, it's going to follow the order plus, minus, plus. This means that all of the x values below negative 1 will make this positive, and all of the x values above positive 4 will make this positive as well. Everything between negative 1 and 4 will make this negative. We are looking for when it's less than or equal to 0, which means we are looking for when it's negative. So we are looking for the values between those 2 points. Slight problem. Before we continue, our LCD was x times x plus 2, which means that x cannot equal 0 and x cannot equal negative 2. Let us put that in on the number line. 0 is somewhere over here. X cannot equal 0. It also can't equal negative 2, but that's beyond the values that we're looking for. We're only looking between these two. So we can say x is greater than or equal to -1, less than or equal to 4, but x cannot equal 0. Or we could say x ranges from -1 all the way up to 0, and then from 0 all the way up to +4. Although this way is much easier to write it. Other notation we could use for that there is we could say x is an element of, including -1 all the way up to +4, also including +4, but x cannot equal 0. Right, let me just run through that again. The different notation I used was, I said square brackets, which means we're including it, greater than or equals to, less than or equal to. X is an element of that, but x cannot equal 0. Number 5, read square root of -2x plus 12 is greater than or equal to x minus 6. I'm going to start by getting rid of that square root sign by squaring both sides. That means that -2x plus 12 is greater than or equal to x squared minus 12x plus 36. One slight problem though, we know that we cannot get a square root of a negative number. That means that -2x plus 12 has to be greater than or equal to 0. That means that -2x has to be greater than or equal to -12. Divide through by a -2, that means that x is smaller than or equal to +6. This is our restriction. Alright, from here I'm going to start by taking everything across. That will become -x squared. -2x plus 12x is going to give me plus 10x. Plus 12 minus 36 is minus 24, greater than or equal to 0. Divide through by a negative, that means that x squared minus 10x plus 24 is greater than or equal to 0. X minus 6, x minus 4, greater than or equal to 0. That takes us to our number line. One critical value of 4, other critical value of 6. It always goes plus minus plus because I factorized from a positive a value. We are looking for when it, hold on, when I divided through by the negative, I forgot to change my sign. Remember, when we divided through by that negative, we changed the direction of the sign. So we are not looking for when it's positive any longer, we are now looking for when it's negative. That means we are looking for the values between 4 and 6. That means that x is greater than or equal to 4, less than or equal to 6. Or we could say x is an element of from 4 all the way up to 6. Does that follow our constraint or our restriction? Yes, it does, because our restriction says that x has to be less than or equal to 6, which holds true. Now, in the examples that I've given you to do, none of them involve dividing through by a negative. There is a special note to remember when we divide by a negative with regards to inequalities, and we are going to go through that now. Let us use the example of -3x is less than or equals to 9. Now here is the rule that you need to remember. When you divide through by a negative, always change the direction of the sign. It was not important to do with equations, simply because equations had an equals to sign, and it doesn't matter which side an equals to sign is facing, or rather put, an equals to sign does not face any direction because both sides are equals to each other. In this case, however, one side is bigger than the other side, so you've got to be very careful working with this type of sign. If I have negative 3x is less than or equals to 9, the shortcut would be divide 9 by negative 3, but change the direction of the sign so it becomes x is greater than or equals to 9 divided by negative 3, which means that x is greater than or equals to negative 3. And that brings us to the end of the 6th algebra tutorial, Inequalities. Before moving on with the next tutorial, which deals with advanced cumulative algebra, which is basically all of the algebra we have done thus far from grade 0 up until now. Before you move on with that, I want you to go through the exercise that's in your workbook.